Real-time operating systems sound complex only until you realize they exist to make sure important tasks happen at the right time, every time. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition so you understand why systems behave reliably under pressure, not just how code is written. Most students think real-time operating systems like FreeRTOS are advanced software meant only for large embedded projects, but in reality, they exist to solve a very practical problem: how to manage multiple tasks on a small system without missing critical deadlines. Unlike general-purpose operating systems that focus on speed or user experience, real-time systems focus on predictability and timing. To see this intuitively, think about a busy kitchen in a restaurant. Some tasks, like serving food, must happen on time, while others, like cleaning, can wait. A real-time operating system acts like a strict manager, prioritizing tasks so critical actions always happen when required. FreeRTOS does exactly this by scheduling tasks, managing timing, and handling resources in a controlled way. At a deeper level, FreeRTOS allows engineers to divide an application into independent tasks that run seemingly in parallel. It manages task scheduling, intertask communication, and timing constraints, ensuring that high-priority tasks respond immediately, while lower-priority tasks use remaining system time. This structure makes complex embedded systems predictable and easier to maintain. On a larger scale, real-time operating systems are essential in applications where failure or delay is unacceptable. Medical devices, automotive systems, industrial automation, robotics, and aerospace systems all rely on RTOS environments to guarantee correct timing and reliable operation under all conditions. In real engineering practice, FreeRTOS is used when building scalable embedded systems that require multitasking, precise timing, and robustness. Engineers use it to manage sensors, communication, control loops, and user interfaces without losing determinism. These systems evolved as embedded applications grew too complex for simple loop-based programming. Now that the intuition behind real-time operating systems is clear, the next step is to explore advanced task scheduling and real-time system design, where timing guarantees become measurable and enforceable. And that's exactly what we'll cover next here at the Learning Studio.